Hello. You should see the desktop. You should hear my voice by now. Is everything seem okay? Okay. Is everything, can you hear me?
Yes.
Yep.
Okay, great. Thanks. Okay. A lot of people are still coming into the meeting. Okay. First thing, see people, I think everyone's maybe here. All right. First, see, no, okay, on the syllabus, the second exam is actually going to be a week from this Thursday. Okay, see, that'd be a week from this Thursday. So I'm going to have review problems up by this Thursday, maybe even by tomorrow. I started working on them. The exam will be on essentially on if statements and for loops and methods. So it's going to overlap a little bit with the last exam, and it'll be also what we've covered since the last exam, which is mostly for loops. And we did a little bit more with if statements. So I'll have the exact list of what the exam is going to cover and a review and a bunch of review problems like last time they'll definitely be there by Thursday and maybe by tomorrow evening. Okay, so look for that. So that'll be an exam just like the last one. We'll do it the same way as the last one, and that'll be a week from this Thursday. Okay. I haven't put an announcement about that on the website yet. So I'll put a link up here to the review problems and stuff like that. So when I got the review problems done, I'll put a link to them right up here. Okay. And let's see. Today, there's no new reading assignment because we're going to be talking about this stuff today and probably on Thursday also. Okay. So the reading assignment is these sections here. So there's no new reading assignment. It's a fair amount here. Now, most of this is actually review. We've talked about these ideas before, and they're important enough. We're going to go over them again. The one thing we haven't said much about was this one, and we'll be talking about that on Thursday. We probably won't even, I don't even know if we'll get that today. So we mostly today be reviewing like these first couple things. We need to say real carefully what we mean by method return values. We've never really said we've never worked with many examples of method returns. Okay, and let's see. Anybody got a question? Anybody have a question about stuff so far?
Will we be getting our test scores soon back?
I hope.
Back soon.
Yeah, I hope so. It's just a lot of grading, and I can't. Yeah, I've been mixing up the grading with creating new homework assignments and working in my other classes. The truth is, it's just taking a long time. Yeah. So I hope.
It's okay.
Yeah, I'm sorry. It's just it's it's a lot of students, a lot of grading. It just yeah as they pack more students into classes, there's a price to pay at some point. Okay, so I'll try to get them done as quickly as possible. Now, has everybody seen their first two the first two homework assignment grades? You should have seen those, right?
Yeah.
Yeah, okay, yeah. So if anybody, yeah, you should have seen your first two programming assignment grades. If you didn't, send me an email. If you turned them in, some people didn't turn them in. But if you turned them in, you should have seen your grades for the first two programming assignments, and the third grade should be up there pretty soon also. We're very much almost done with grading the third assignment also. But you should have gotten your first two programming assignment grades. Okay. Anybody got any other questions about stuff so far? Okay. Okay. So okay, now we want to talk about procedures. Okay. Now we did these examples. Let me clean up here a little bit. I have to clean up from my last class. I haven't deleted everything from the last class. Okay, so we were doing these, oops. I forgot to update the web page. Okay, so they're on the, okay. If you go to the other, I'll fix this after class, but if I go to the Monday, Wednesday class, there's the 2 zip files. Somehow I've got the address, I've got some misprint in the page for this class. Okay, so I got to fix these after class. Okay, so I've got we were working on these examples, and then we're going to do some other examples here with turtles. Okay, now if we look at these, we were mostly doing these as examples of nested for loops. So here's one of them. Let me open it in Dr. Java. Get Dr. Java up running. Okay. Now, mostly it was an example with nested for loops. There's the nested for loops. But it was also written as a method. Okay. So right now we want to talk about more or less the method aspect of it. We were talking the other day, we were mostly emphasizing the nested for loop aspect of it because these were nice examples of nested for loops. This drew this pattern, and I did it 3 ways. So this was one way, this was another way, or I'm sorry, 2 ways. So there was just 2 slightly different ways. Well, this way wrote it as nested for loops, and this way wrote it as nested for loops with an if statement. Remember, this one wrote it as an outer for loop and 2 inner for loops. This one writes it as an outer for loop, an inner for loop, and a if statement. Okay, so slightly different ways. But what we want to emphasize now is the idea that it's a method. So you can call it, so like what that means is I can call it as many times as I want with different values for the parameter. So I can get a size 8 triangle. Or I can get a size 8 triangle. I can get a size 3 one. I can get a size 9 one. Okay, so I can compile and run. Okay, the beauty of methods is you can call them over and over again. They let you reuse code. So there's a size 6, a size 8, a size 3, and a size 9. Okay. The method, this code has a number, a variable in it that can be changed when you call the method. So there was this notion that there was a size parameter to this code, and the size parameter is a method to the is a variable parameter to the method. So when I call this method, this goes here. Okay, and that makes this size 6. When I call the method this time, 8 goes here. So now this is size 8. When I call the method this time, 3 goes here. Okay, and in a minute we'll use the Java visualizer to watch that, what we call parameter passing. Okay, what we're going to do is we want to talk in detail about the methodness of this, not so much the for loops. We're not going to pay attention to the for loops today. We're going to pay attention to what we call the method call here, the method definition here, and I'm calling that method. Okay, and this method definition. So here, actually, what I want to do is make some notes. Okay, here's what the ideas we want to talk about. We want to talk about method definitions, and we want to talk about method call. These are the 2 key ideas. When you have a method, you have to write out what it does. Then at some point you call the method to make use of it. So we've got these two ideas, method call and method definition. Okay, method definition has got several pieces to it. There's the method. There's something called the method declaration. The method declaration is this first line, and it tells you the method name, the method return value, which we haven't said much about, and the method parameters. Okay, so the method declaration has the method name, the method return, and the method parameters. Okay, right. Now what else is there in the method? After the method declaration, there's the method body. Over here, that's the code. That's what goes in between these braces. So every method has its declaration line, which tells you what name you chose for it, what parameters you've chosen for it, what type they have, what name each parameter has, and you specified, which we haven't talked about yet, what it returns, what kind of answer it gives back. Void means this thing doesn't give us back an answer. This method doesn't give us back an answer, so we haven't talked about that yet much. Okay, all right. Now, so a method definition has a declaration, which has got three pieces to it, and then there's the method body. So a method definition's in two pieces. Okay, all right. Now, the other thing is the method call. See, then up here, I call the method. Okay. The main thing about a method call is that there's this thing here, which we call the method arguments. The arguments are the argument values go into the parameter variable down here. Okay, so in a method call, we have arguments. Okay, the method arguments are passed into the method parameters, okay, which are up here. Whoops. See, the method parameters were part of the method declaration. When you do a method call, you have method arguments, which are, we use the word passed. We pass, the method arguments are passed into the method parameters, okay? We also have the idea of what's called the flow of execution. When we do a method call, what we're really saying, we'll see this in a second in the job visualizer, you're saying jump down to line 24, which is where the method body begins. See, this says jump down to line 24 and do the method body. Now, just before you do that, you take this argument and put it in that parameter, and then you start up the method body. Okay, so the method call has this, but it has this idea of the flow of execution. Then when you get to the end of the method body, you'll flow back up here to where you call the method. So this means flow down here, do what's in here, then come back up here. Then this will do the same thing. It'll do a method flow from here down to here, do what's in here, then come back up to here. Okay, so method calls give us what we call a flow of execution. Okay, let me save this. Okay, so we need these words. We're going to be using these words a lot, and our goal is to get used to using these words when we talk about methods. Yeah, real important. The method definition and the method call. We've done a lot more method calling than we've done method definition, because we did method calling pretty much every time we called a method on an object. So when we were calling string methods, we would do method calls. So we've done more method calls than we have writing our own method definitions. So what we're really doing now is we're switching to emphasizing writing method definitions. Okay, so here I've written the method definition. So right now we're going to emphasize just these words and how the method call and the method definition work together, and then start emphasizing that's where CodingBat comes in. CodingBat is having you write method definitions. CodingBat, everything you do on CodingBat is you're writing a method definition to satisfy a certain requirement. You don't see the method call. And the funny thing about CodingBat is you never see the method calls because the method calls are done by the CodingBat website. They call your method with all their test cases. So you write the method definition and they write the method calls with their test cases. So it's a little bit kind of backwards than what you're used to. But so far we've been doing more method calls, but CodingBat emphasizes the method definition. So that's what we'll do more of those as we go along. Okay. Now let's take this example we were doing over here, puzzle 2, and move it up to the Java visualizer so that we can watch it do these things. Okay. So I'm going to do, actually, I'm just going to save space. I'm just going to do one of the two versions of this. Okay. So let me copy this up to the Java visualizer. We put our code in there. I'm going to get rid of, just to save space, you can just use, we only need one version of the method. So let's look at these method calls. Okay. So now go into, let me actually use a small number here so that I don't have so many for loops that loop through. Okay. So make that a 3 and make this one a 5. Okay, so we'll do 2 method calls. We'll do 2 method calls, keep the number small so there's not so many loops to do. Okay. Okay. All right. Now here's where I am. I'm starting at line 5. I'm in the main method at line 5, and I'm about to call this method here. Okay. When I call that method, I'm going to jump down to line 11. But when I jump down to line 11, I'm going to get a new what's called stack frame over here to show me that I've started a new method. Okay. So I'll create a new stack frame, and that's actually one of the things that is in our vocabulary. In this vocabulary over here, part of method calls are stack diagrams. Okay, these were mentioned in both of the textbooks. So we'll see that every time there's a method call, you get a new stack diagram. Okay, so let's watch that happen. So make the method call. Okay, notice I jumped from 5 to 11. There's the old stack frame. Here's the new one that has the variable size in it. Okay, so I've got I have no notice there's no variables up here. There's one variable down here that's the parameter. Okay, and notice that the argument got passed to the parameter. See, 3 got put into size. Okay, so the argument got passed to the parameter. Now, notice that I have this for loop here. Now I'm in the step 11, and I'm actually, remember, you enter for loops here. So I'm now going to do now I get a new variable over here. This variable is called a local variable. See, this was a parameter variable, so now I've got a new idea. Let me add it to the list of vocabulary words. I get what are called local variables. Okay, that the local variables in addition to the parameter variables. Okay, so the the method argument is passed into the method parameter. So I have the method parameters, but now I also have local variables. Okay, so you see that over here in the stack diagram, there is the I that's part of this method call. Okay, now I is gonna now the next thing to do is go to this part of the for loop and check that I is less than size. Okay, that was true, so now I'm down here. Well, now I'm in this part of this thing, and I'm creating another local variable. So now I've got a second local variable that belongs to this method. See, it belongs to puzzle 2a, belongs to this method. Then I'm starting to do the looping. So I'm going to loop a bunch. The local variables are changing. When I get to I is 4. Okay, now I is 4. Now that was the thing that, see, there's only supposed to be 3 rows, so I is 4. I'm right here, and this is going to fail right now. Now I've hit the part where this is going to fail. I've done my 3 rows. I is hit 4. 4 is not less than 3. So now this is going to fail. And I'm going to go to the end of the for loop, which takes me to the end of the method. Now I'm ready for the return. See, I've reached the end of the method. So that's what one of our vocabulary words was, this idea of return. Where is it? Okay. Now, we're not actually using a return value here, but we've got to the place where the method is, this is part of actually the flow of execution. The method needs to return to where it came from. So right now, our method doesn't have a return value. There's both returns and return values. Our method now returns, but it doesn't have a return value. In our case, return means to go back where you were called from. Okay, so what's going to happen? We were called from line 5 of main. It was line 5 of main that called this method. And see, the stack diagram tells us that. We're in line 23 of puzzle. That's the very last line. That's the closing brace of puzzle, of this method. We're at the closing brace we're about to return, and we're return to line 5 of main. Now, line 5 is actually done, so we actually going to end up returning to line 6. Later on, we'll see an example where there's more to do up here, but right now there's no more to do up here. So when we do the return, the next thing is going to go to line 6, because line 5 was actually done. Now notice that the stack frame disappeared. See, if I go back, see there's 2 stack frames. We are at the end of puzzle. Puzzle's got this stack frame, but we're going to return. When we return, that stack frame disappears, and this guy's on top. Okay? So that one that was on top goes away, and this one is now on top. But now we do another method call. Okay, so now we're going to do another method call. We're going to jump back to the beginning of the method, and we've got a different value for the parameter. Notice that now the argument is passed to the parameter, and it's a different argument than last time. Okay, now let me go and modify this code a little bit to show you some more ideas. I could go ahead up here and put a variable, int size equal 3. And then I can use the name size here. Okay, and then here I could say size equal 5. And I can then use size here. What I'm doing is I'm creating a local variable for this method. I'm giving main a local variable. Now I purposely gave it the same name as this. And the key idea here is that this parameter variable and this local variable are not the same thing. They're different variables named size. Okay, when you see the word size here, it's not that one. When you see the word size here, it's that one, because see, these braces are what we call the scope of a variable. This variable lives between those braces. This variable lives between those braces. So when I'm in these braces and I see size, I look for the size that was declared locally. When I'm in these braces and I look for size, I have to find the size that's declared locally. If I change this to Bob, this program won't compile. This size has to be local. Java's not going to glom on to that variable up there, even though you see size on the page. You say, okay, size is size. See, I got an error message. Cannot find symbol size. Well, how could it not find size? You and I are smart enough to find it right there. Okay, notice that you don't read programs the way computers don't read programs the way humans read programs. It says it can't find size. Well, you and I know how to find size. We can just look at the page and find it right there. But that size is out of scope. It doesn't exist in this scope. So this size doesn't have a declaration in this scope because I changed this name to Bob. If I change this to Bob, that guy's okay. But then if I try to visualize it, now it still says cannot find symbol size. Now it's this one it's still the same problem. This one has never been declared. This Bob is that Bob, but this size is undeclared. He cannot be, you can't just say, I can find size on the page. I'm smarter than a computer. I found it right there. But that's not the rules of the language. The rule of the language is that size is only valid up until that closing brace. This size has to be found before that opening brace. Well, actually, it has to be found before this method declaration. So it has to be found there. So now you go back up and you don't find any size. See, if you go back up through here, you don't find size. That's why this guy can't be found. Okay, so this size has to be declared somewhere between up there to there, and it is. It's in the line right before. So you have to have declared it before you can use this variable. You have to declare it. Where do you have to declare it? Before the beginning of the method. Okay. This variable needs to be declared before I can use it. Where does it need to be declared? It needs to be declared. It needs to be declared somewhere before the beginning of the method, and it isn't. So Java complains. Okay, so this, no, let me put, okay, so now I got it back to where it should be. This size is not that size. Now let's watch it in the visualizer and we'll see that we'll see two sizes. Okay, now see, I created a local variable on line 5. Line 5 created a local variable in main called size. Now, what happens here is that when I use the word size here, Java looks up the value of size and copies the value of size into that size. Okay, it's just a coincidence that I use the same name for these. What Java really does is it says, whatever number is stored in here, that's the number I copy down to here. So it's an argument value. Now, if I go over here to the, here, I should point out method argument values are passed to parameter variables. There's actually a slight difference here. Arguments are values. They're not variables. Arguments are values. So in this example over here, when I do the argument passing, I don't pass size. I pass what's in size. I go that the value. Later we'll see that there's an important distinction there. So I get the argument's value and pass it to the parameter variable. So then when I click forward here, there's the two sizes, the one local to this guy and the one local to this guy. We just passed that argument to that variable. Okay, we passed that argument to that variable. So 3 ended up over here. Okay, so we pass an argument value to a parameter variable. Okay, and these subtle distinctions are going to become more and more important as we go along. You'll see that I'm not being ridiculously picky when I talk about these words, because compilers are ridiculously picky. So I'm being as picky as the programming language is. So it's way more picky than you would be when you read English, but it's what we need to be to understand what the programming language is doing. So we need to use this terminology. Otherwise we get all mixed up, like this size, and if you're not careful, that size and that size just start blurring together. And there are actually languages where they are blurred together. There are programming languages where this size and this size just mean the same thing. There is only one size variable in the whole program. Java's not, none of the modern programming is like that. But if you go back in the old days, there were programming languages that were like that. Okay, so Java has what we call the scope of each variable. A variable lives between braces. Every variable, like this size, lives between those braces, the braces of puzzle. This size lives in the braces of main. That's what we call variable scope. Okay, so every variable lives within a pair of braces. Okay, now actually later we'll see that this I, his scope is just that brace. See, we haven't built the I yet, but this I will also be a local variable, but this I scope will be from this brace to that brace. And we'll see that, or for example, that J lives only from there to there. When we get to the end of that loop, the J temporarily disappears and a new J has to be created here. This J is not that J. In fact, I could have chosen a different letter here, but I used the same letter, but they're not the same J. In fact, I could have called this a K, but later on we'll change that to a K, and you'll see that if I make this a K, this J still disappears when I get down to here, because this J lives up to that closing brace. This J lives up to that closing brace. This I lives up to that closing brace. And size lives up to that closing brace. See, that's the closing brace of the method. This was the closing brace of the outer for loop. This is the closing brace of the inner for loop. J lives to there. This J lives to there. This this I lives to there. This size lives to there. That's what we call scope of a variable. Okay, actually, so now let me step forward. There's I. See, I didn't create it till I got to line 13. So there's I created in line 13. Okay, now do some J's. Okay, notice that J disappeared. See, go back. I was at this step here. I'm checking this condition with I equals 3. With J equals 3. I'm checking this condition with J equals 3. This condition is about to fail, so I'm leaving this for loop. See, I just left that for loop. I joined this for loop. I haven't quite started it yet. My J disappeared because this J went out of scope because I'm now past line 18. Now I'm here. I'm about to create a new J. So now I create a new J. This J lives up to line 22. Okay, so then I do some more for looping. Whoop, oh, I went back. Okay, I do some more for looping. Okay, notice I just left this for loop. I'm at line 23 and I lost my J. See, if I go back one step, that J is now going to make this test fail. So that J is going to make this test fail. So I'm going to leave this for loop and go to the system.println. But the J went out of scope. So the J is gone. Okay. Now I'm here. I'm going to print a blank line. Now I'm going to go up to here and increase I. Okay, now I'm at this guy here. I'm going to increase I to 2. Now I'm going to do this guy here, check that I is with less than size. And now I'm ready to do these inner loops here and create some more, create a J. J lives for a while, then dies. Do the next loop, new J. J lives for a while, then dies. Do the print line. Okay. Check. Now I'm up here. I'm going to increase I again. I is 3. Okay. Now I'm going to go over here. Do another loop here of I's. Do more I's and J's. Okay. Go back up here one more time. I'm up here. I'm about to make I 4. Now I is 4. This one's going to fail now. When this one fails, I leave that for loop and my I disappears. So when this one fails, see, my I disappeared. Go back one step. So I'm about to fail this one. I is 4. 4 is not less than 3. So this one's going to fail. That's going to take me out of the for loop to line 25. And my I disappeared also. Size is still there because I'm still inside this method. I haven't left the method yet. I'm about to leave the method. When I leave the method, then size will disappear. This whole stack frame will disappear. Okay. And now I'm back up here in main. Now I'm back in main. Okay. All right. Now let's do another little example. Let's change this thing a little bit more. Okay. Let me do something just kind of dumb here. Let me decide that whatever size is supposed to be how many rows are in the triangle. But this method is going to say, whatever you tell me, I'm going to do one more row. Okay, so it's going to take its parameter and change it, which is, it turns out to be, that's not necessarily a good idea, but it's allowed. So it's going to go ahead and change the variable. See, it's a parameter that's actually a variable, so it can be modified. And we'll see, that'll show us once again that this size is not this size, because this one will stay 3 while this one gets increased. So let's just kind of watch this happen. Okay. Local variable size is 3. There's my local variable size. I'm about to make the method call. The value 3 is going to get passed to that parameter there. Okay. All right. So the value 3 from main got passed to that parameter. Now I'm going to bump that up to 4. Notice that it didn't affect this one. See how that one's still 3 after I made this one 4? Because they're different variables. You see it here real clearly. You see it clearly here that they're different variables. I changed the local size to 4. That didn't affect this guy's local variable. This size just has another existence. See, they're separate places in memory. One size is down here, the other size is up here. Okay, so this didn't affect, this one didn't affect this one here. Okay, now let's do another thing. When you have methods, one of the things about methods is you look for things in there that could be parameters. Like right now, I'm drawing a picture. Well, go to the end. You know, here's the picture. I'm drawing these triangles. Let me just change this. So instead of putting leading spaces, I put leading dots. I want to put leading dots there instead of leading spaces. Well, that's easy to do. I change space to dot. Okay. Go look at the result. And I thought, okay, great. You change spaces to dots. But then the obvious thing is, well, what if you want to make that a parameter? You know, make it so that you can, the caller gets to choose what letter should be in the leading space, in the leading place. So let's go ahead and give this thing another parameter. Let's give it a char C, and let's print the character. then let the caller choose what the character can be. So I'm going to make this a dot, and I'll make this one a $sign. Okay. Okay. Now just visualize, and we see that now we have a more versatile method. We have a method with more parameters, and it can print leading dots or leading $signs. Yeah, maybe you like this one. Yeah, whichever one you like, you can continue to use. Okay, this one had leading dots. This one had leading $signs. Okay, so now let's watch it actually happen. See, now we're passing more parameters. Okay, when we get to this method call, we take that variable and look up its value, and we take this. Notice this is a value, it's not a variable. So notice here, this argument is a variable, so I have to look up its value, and this argument literally is a value. It's just a dot. Okay. Okay. So I create my local variable size. Now I'm about to make the method call. Size is a variable, so I have to look up its value because I passed the value to the parameter. This guy is a value. See, there's no variable there, it's just a symbol dot. So that value gets copied to this variable. So if I go down here now, see now puzzle has 2 parameters, and that value got copied into that parameter, and this value here got copied to that variable there. So this value got copied into this variable here. Okay. And then when the method gets down here, it'll use the variable value instead of a fixed value. Okay. Now I like that idea enough. Let me give it another parameter. Let me call this C1. And here, instead of printing a number, let me print a C2. So I'm going to create triangles with 2 chars, C1 and C2. Okay. And here I'll say something like char C equal, make it 0. Okay. And I'm going to put, so now I'm saying printing a triangle with a dot in front and whatever this holds. So it's going to be dots followed by zeros. And I'll make this one zeros followed by $signs. So this line will be size 3, and it'll have zeros followed by $signs. This one will have dots followed by zeros. Okay. Now, just check that that's what we get. Oh, what did I mess up? Oh, I forgot the semicolon after that. Now what did I mess up? Oh, I changed the names of these. Okay, so this one is C1 now. Okay, so it's C1 for the first parameter, C2 for the second parameter. C1 is what's at the beginning of the line. C2 is what I'm putting at the end of the line. I can look at my output. See, dots followed by zeros, zeros followed by $signs. Okay, now let's watch the parameter passing. Okay. So local variable size with a value 3, local variable C with a value of the letter 0. Okay. Now make a method call, use the value of that parameter, use that value there, and use the value, use the value of that variable, the value that's right there, and the value of that variable for these 3 parameters. Okay. So this is parameter, we call this parameter passing. We pass the values of the arguments to the parameters. So if I click forward, I see here 3 parameters, size, C1, and C2. This value got copied to that parameter, that parameter. This value got copied to that parameter, and this parameter got its value from this value right here in the method call. So variable, value, variable. Okay, look up the value of that variable, grab that value, look up the value of this other variable. Okay, then create these local variables, and then again, I'm still playing this game that I'm changing the value of size. I make this size one more than it was, just for the heck of it. Okay, and now I'm going to go into the for loops, create a local variable I, create a local variable. Notice I picked up a lot of local variables here. Now I've got 1, 2, 3, 4, 5 variables. Main still has only 2 variables, but now puzzle's got 5 variables at this point. These 2 are local variables. These 3 are parameters. They're not quite the same thing. These 3 are parameters. These 2 are local variables. In fact, they're loop variables, so they come and go as you do the looping. So you see that if I step forward a little bit, see J just disappeared on me. If I go back, J hit 4. That was the last it was supposed to be. When I finish this for loop, I finish that for loop, I lose the J, but then I get another J. Actually, I said a minute ago that I could change this to another letter if I wanted. Let's make this loop use K. Okay, so now these 2 loops are using different variables. So now you see that the J disappears and it'll be replaced by a K in the other loop. Okay, there's the J. J goes to, okay, oops, I'm sorry. Okay, J hit 4. That's the last J value. I'm going to go from line 17 to line 21. I'm going to start the next loop. When I finish the loop that goes from, when I finish the loop that starts at 17, I finish that loop, I lose J. Now I start this loop and I gain a K. See, it's a different variable. It's a different loop. So even if I use the same letter, I'm still supposed to think that they're different variables. So even if I did use J here, I'm supposed to realize that that J is not that J. Okay, they are not the same J. And you can kind of see it better here. I replaced the J variable disappeared and it got replaced with a K variable. Okay. At this point, like right now, I've got a J variable, finish the J loop. Now I'm about to start this loop, but there's no K yet because I actually haven't started the loop. I'm at this point right here. I create K. So there's the K variable. Now I'm checking it. There's the next part here. That's going to be true. So now I get into here and I print something. Okay. So local variables versus parameters. Parameters are variables. You can change them. But the parameters live all the way up to the end of the method. The local variables are called local because they may actually not even live all the way to the end of the method. Now, size will live all the way to the end of the method, but I lives only to the end of the for loop. J lives only to the end of that for loop. K lives only to the end of that for loop. So every variable has a slightly different scope. Size, char1 and char2 have a scope that goes to the end of the method. I goes to the end of the loop, and K goes to the end of the loop. I'm sorry, I goes to the end of this loop, J goes to the end of that loop, K goes to the end of that loop. Okay. All right. Now, let's see. So we've talked about a bunch of ideas here. Let's see. Now, if we add to our vocabulary list, we have local variables have scope. We can talk about the scope of a variable. Okay. So the scope of a variable is whatever braces it's declared in. So the parameter variables, their scope is to the end of the method, but the local variables, their scope it just depends on how you created them. If you created them in a for loop, they only live to the end of the for loop. If you create a local variable at the beginning of a method, it would live to the end of the method. Okay. All right. I think, let's see, let's see. I think these are all the words we've been using. I think this is a list of all the words that we've used in talking about methods. Okay. Now let's see, what else can we do? Just to, the idea here is to try different things. I think we've tried all, I think this is all the ideas we can use. Let me show you. Okay, now let me switch to some here we've been using tables and strings to emphasize methods. Let me go and show you a different kind of method, turtle methods. Okay, got Dr. Java. Okay, now we can't use turtle methods in the Java visualizer. It's just Java visualizer is just not powerful enough to be. We can't load our own. We can't load the turtle code into it. Like I loaded the turtle code into Dr. Java. I made it part of that folder you download when you download Dr. Java. So when you download Dr. Java, like I have it on my hard drive, so I'm going to where I downloaded it. So here's where I downloaded Dr. Java. See, I put it in a folder called CS123 version 2, okay? So if you look in that folder, I put a folder called config, and there's where I put the turtle code. See, I put the turtle code in the folder with Dr. Java. So all the turtle code is in this thing called a jar file. Jar stands for Java Archive. An archive is where you store things. So a jar, and also it's a pun. Programmers love puns. What's the pun? Jar stands for Java Archive. It's where you store things. Why did they think that was a cute pun?
Probably because they store things in jars.
Right, yeah, because you store things. So they thought that was really clever. And as you learn more programming, you'll see that many times people judge your code by how clever you are with puns. There are puns everywhere in the programming world. Lots of like C++ is a joke. Does anybody remember? I think I mentioned it. What's the joke in C++?
Well, it's C plus sum, and plus plus is what programmers use to increment by 1.
Right, so you took the C language and did what with it?
You added something.
You added something to it, which took the C language and made it an object-oriented programming language. So it was C with something added to it. So the joke was, call it C++. If you start looking around, you'll just see jokes everywhere in the name of programming languages, and in just in general. There's just puns everywhere. Another famous pun. Let me show you another one. It's a real clever pun. Let's see. Let me find it. There's a programming language called Clojure. It's spelled C-L-O-J-U-R-E. Okay. The joke is very subtle. Clojure is built on top of Java, so that's where the J came from. And Clojure is really a pun on the word closure, like as in close, because in programming languages, we have something called a closure, which is spelled like this, which is an important concept in advanced programming languages. There's something called a closure. So somebody designed a language that used closures, and it was built on the Java virtual machine, so they called it Clojure, spelling it with a J. Okay, and spelled it with J-U for some reason. Yeah. So so the name of the language is a pun. Okay, and you'll see this everywhere. Programmers love puns, and they name things with puns all the time. So jar files are Java archives. Now the Java visualizer won't let you add a jar file to it. That's the problem with the Java visualizer. I can't somehow take that jar file and add it to the Java visualizer. So I can't add turtle graphics to the Java visualizer. But I can add the jar file to Dr. Java. Dr. Java is smart enough to allow you to add jar files. See, Dr. Java is itself a jar file. See, Dr. Java is itself a jar file, and it lets you add jar files to it. So that's what I did to add. Turtle graphics to Dr. Java. Okay, so now I want to show you how you can do something like the Java visualizer in Dr. Java. Because right now we have methods, and we're going to call the methods. Okay, so here I've got a method that draws a square. It takes in a turtle, and it tells the turtle to draw a square of size. And drawing a square is real easy. The turtle turns 90 degrees, goes forward, turns 90 degrees, goes forward, turns 90 degrees, goes forward, turns 90 degrees, goes forward. So that draws the 4 sides of the square. So, and you go from one side to the next side by turning yourself 90 degrees and going forward, okay? So then up here, I create a couple turtles, and I'm gonna make one turtle turn left and then draw a square. And I'm gonna make the other turtle turn right and then draw a square. I can compile this, and I can run it. There's my 2 turtles. They started over here. One turtle turned to the right, 45 degrees. Then he moved forward 200 steps, and then he drew a square. The other turtle turned left 45. Remember, turtles start at the origin. They start at the 0. He turned left 45 degrees. That's negative 45 degrees. Negative is that direction, counterclockwise. He stepped forward 200 steps, and then he drew a square. So you get these 2 look like flags. Okay, but notice that when I ran that, it just popped up on the screen. Okay, what if I want to step through it like we do in the Java visualizer? What if I want to watch these steps happen? Well, in the Java visualizer, we can do that. It does it automatically. Dr. Java will let you do it also, but it's a little bit tricky. It doesn't do it as elegantly or as nicely as the Java visualizer does it. So here's how I do it. It involves using this thing called the debugger. It's called a debugger, not a visualizer, because it's only used mostly, people use it for finding mistakes in their code. If you've written a program and you don't know where the mistake is, if you step through it like we do with the visualizer, you can step until you see something happen that you didn't expect. So the idea is that we've been calling this the visualizer because we're using it to learn how a programming language works. The emphasis in Dr. Java is not to see how a program works, it's to find mistakes in your code. So it really is the same thing. It's visualizing your program, but the point of view is visualizing to find mistakes, not visualizing to learn. Here, the visualizing was to emphasize learning, for you to learn how programming languages behave. Here, it's a tool for finding bugs. So you go up here and you start the debugging mode. So this new window pops up. Now you have to do something kind of quirky. Okay, notice when I start my visualizer over here, the visualizer starts on the first line of my code. Okay, now the Dr. Java debugger doesn't work that way. It will not stop automatically anywhere. If I run the program, it runs it. It didn't stop anywhere. Even though I'm in the debugger, I'm in the visualizer, it didn't visualize anything. That's because I have to tell it where to stop. See, the visualizer automatically stopped at the first line of your code and then let you start stepping forward. In Dr. Java, you have to tell it where you want it to stop. So I want to stop at the first line of code. So I click on my first line of code. Notice I put my cursor there. And I go up to the debugger, and I say toggle breakpoint. Breakpoint are, see, now I get that big bright red line. That big bright red line is kind of like that yellow line, but it's not the same thing. It is not the same thing as the yellow line. You'll see in a second. The red line means that the debugger will stop when it gets to there. Okay? Now that I have the debugger set, now I can tell it to run my program. When I run my program, it will then stop at the debugger. Okay, so let me just show you that. Let me run it. Okay, now see it turned blue. The blue line is like the yellow line over here. It's the blue line that's going to step through my code, just like the yellow line steps through my code here. Now, the forward button here is over here in step over. Okay, I step over that line of code. All right, so notice that here it's just simple. It's just a forward button. Here, notice there's a step into and a step over. I'll tell you in a minute what the difference are between those. But right now, I want to step over line 6. See, now it took a little while to do, but see that popped up the world. Line 6 created the world. Now the blue line is just like the yellow line over here. It tells me what the next line of code is. So see, as I step through, the yellow line moves forward to tell me what the new line of code is. In Dr. Java, it's a light blue line. The red line stays there to say that that's where your breakpoint was. That's the thing that said that's where you halted at. Now I'm stepping through my code. Now I created the world. Now if I step over line 6, I created a turtle. Now if I step over line 8, I create another turtle. Now I got 2 turtles on top of each other. Now if I step over line 9, I make the one turtle turn to a right. You can kind of see that the turtle that was underneath turned right. Then I make that turtle move forward. Okay. Now I get to square. At this point, I can do one of 2 things. I can either step into or step over. If I say step over, it just acts like these did. It just does square. So let me do that. Step over. I drew the square. Notice I did not go into the square method. I stepped over the square method and just did it. All right. Now look at line. Now I'm at line 12. I'm about to make this turtle step. I make that turtle look to the left, make that turtle go forward. Now I'm back to square. Now I'm going to change. I'm going to say step into. Now, see, in the Java visualizer, you don't have a choice between stepping over and stepping into. When you get to a method, you always step into the method. Yeah, see, the Java visualizer is simplified. It doesn't give you a choice of stepping over or stepping into. You just go forward into that, which is, for the point of view of here of teaching, that was a smart way to design it. That was a very clever, make things simpler, less choices, just forward always does the same thing. When you get to a method, it steps into the method. But Dr. Java is a little bit more versatile, also makes it a little bit harder to use. You've got 2 stepping buttons, a step into and a step over. Okay, so now let me step into square. So I'm going to go from line 14 to line 20. See? So I stepped from 14 to 20. Right? Now let me show you something. It's also a little bit tricky. In the Java visualizer, we had these nice stack frames that showed me that I came from line 7 in main, and now I'm at line 14 in puzzle 2. I'm at line 14 in puzzle 2, and I came from line 7. And it shows me my variables real nicely. There were the variables from puzzle. There's the variables from main. Okay. Dr. Java is way more confusing about this stuff. Okay. So what is all in one place here in the Java visualizer is in 2 places over here. Here is the stack. See it says stack here? Here is where it tells you where you are in. See, here's where it says you came from line 14. You came from line 14 in main, and now you're at line 20 in square. See, that's over here. these two lines tell me the same thing that the visualizer is telling me over here. Where I came from, and where I am. Okay, here, this thing tells me at the top of this stack is where I am, and right below it is where I came from. And below that is from the other things I came from. But these are all internal to Java. Notice that I came from a lot of other places which we know nothing about at this point in the course. So there's actually a lot of other stuff in there that you'll learn about as you go through the curriculum. It'll take you years to learn what all this stuff means. But this is where we didn't even get to main. Somehow we had to get to main, and this is all the stuff that led to main. But this is all stuff that's internal to the Java language, and we're not going to worry about it in this course. Notice the Java Visualizer doesn't even try to, the Java Visualizer doesn't show you an endless bunch of stuff down here. It just says you started at main, and then you went into puzzle. That's the best way to think about it. Dr. Java is actually showing you everything. There's a huge amount of stuff that was down here that's very deeply buried in the Java language that I don't even know why Dr. Java shows it to you. It's not very useful, but it shows you all that. From our point of view, we're just interested in the fact that we came from square, and we came from main, and now we're in square. We came from line 14 of main, now we're at line 20 of square. So we jumped from line 14 to line 20. And then if I now do more stepping, you'll see that this line changes. So I will do a step. That step drew something in the output. That step, see, I made the turtle turn right. Now I made the turtle go forward. Now the turtle turns, go forward, turn. Now notice I'm at line 25. See here, it's telling me I'm at line 25 in square. Now, go back to Java Visualizer. The Java Visualizer shows you where you are here and here, but also shows you your variables. See, it shows you your variables. Well, what about the Java Visualizer? Where are the variables? Well, just like everything else, the variables aren't automatic. The variables in Dr. Java, you have to tell it what variables you want to see. So for example, I've got two variables here. I've got a variable called size, and I have to type it in and hit enter, and then it tells me, oh, size is 100. The Java Visualizer automatically shows you all your variables. Whoops, I don't know when I click that. See, the Java Visualizer automatically, very cleverly, automatically shows you all your variables. Dr. Java says, you have to tell me what variables you want me to show you. So, and then here I have another variable called turtle. So I type in turtle. Well, the name of the variable is t. And it tells me that my t is a turtle and it has no name. If I gave that turtle a name, the turtle's name would show up here. Okay, I didn't give, the turtle's name is not t. T is the variable name. The turtle, I didn't give the turtle a name. The name is something that's stored inside of the turtle. This is the variable that points at the turtle. The name is something that's inside of the turtle, and if I wanted to, I could have given that turtle a name, and then I'd see it here. Okay? But notice that in the Dr. Java, I have to tell it what variables to show me, but the Java Visualizer automatically shows you all your variables. Why didn't Dr. Java do it that way? I don't know. You know, the Java Visualizer people were real clever. They thought real hard about this stuff. They wanted to take essentially what is the debugger in programs like Dr. Java or IntelliJ or Eclipse. Dr. Java's debugger actually works pretty much like the debugger in these other IDEs. It's designed to be very low level and kind of hard to use. The Java Visualizer people said, how can we simplify this and make it easier to use? And they did a very good job of it. They did a very good job of making it simpler and easier to use. And I kind of wish the Dr. Java people would learn from the Visualizer people, because this could be made a lot easier to use. The step over, step into is good to have. The step over, step into would be a nice thing to keep. The Visualizer doesn't really need it, but it is a good thing for for Dr. Java to have. It should keep step into and step over, but it should automatically just show you all your variables. And it shouldn't show you this huge amount of stack stuff here that you don't need to know. So it'd be nice if it automatically over here showed you all your variables. Okay. All right. So we can capture a lot of what the visualizer does in Dr. Java, but a little bit harder. Okay. Now notice I'm over here. I've almost finished squaring. Okay. I've almost finished drawing the square. I'm at line 25. I'm going to tell the turtle to make one more forward. Okay. Then he's got one more turn to make. Okay. Now notice that I'm almost done with squaring. Now see, Dr. Java does just like the visualizer does. It highlights the closing brace when it's about to return. If I go over to the visualizer, it does the same thing. If I step through this enough times, I'm going to step through it till I get to the end. Okay, there. See how it goes to the closing brace just before returning. That's the closing brace of the method. Okay, so the Java visualizer and Dr. Java both do the same trick. When you're about to leave a method, when you're about to return, they show the closing brace as being highlighted. Okay, see, shows the closing brace as being highlighted. Now, what that means is you're about to remove this stack frame here and go make this one the top. So you're about to leave this method and go back to main. So over here, this window should go blank on me because this window is showing me the variables in this method. So when I click, I'm going to do another step over. That's another, which is going to leave this method. This window should go blank. And then square should leave here. It should not be shown anymore. And I'll have main at the top. Okay. So let me go one more step. All right. See, now I stepped back here. Now I was at the end of this guy, but see what happened. See how this one went? Well, see how it's kind of funny. Dr. Java shows this in a kind of confusing way. When you leave this method, this stuff disappears. That's not what Dr. Java showed. It didn't show it disappearing. The variables are still there, but they're not found. It's a little bit confusing. They don't exist anymore. It should have shown this is just empty, but it shows the variables you put there is still there, but it claims that they're no longer findable. Okay, and notice that this method here is gone. Now we're in main. See, we're in main. So this stack disappeared, but it didn't quite disappear. It disappeared from here, but it's shown over here as not found. It's their choice of how to do this. I think they should have just made this thing just go away. Just like, see here, when I do one more step, this is going to go away. See, it went away, but Dr. Java didn't quite do it that way. Dr. Java, and you can't go backwards in Dr. Java. Here I can go backwards and forwards. I can go backwards and forwards here. This guy can do it because it's a website, and it actually is not running your program. It just actually has stored your program as a bunch of pages, and so it lets you go backwards and forward. Dr. Java is actually running your program, and it can't go backwards. There is no back button here. Excuse me. Okay, so that's one thing. That's one of the things the visualizer did that's really clever, was let you go backwards and forwards in your program. Okay, that's very, very clever that they were able to figure out a way to do that. Dr. Java doesn't. Okay, most debuggers do not let you go forwards and backwards. They only let you go forwards. There are a few debuggers out there in the world that let you go backwards, but they're very sophisticated debuggers. They have a name for them. I can't remember what they call them, but they're very rare. The Java visualizer is actually playing a trick. It's not running your program. It ran your program and it made a recording of it. So this is actually a recording of your program, and it's letting you step forwards and backwards through the recording. That's actually a really clever trick. And that's why they don't let you run really big programs up here, because they can't store big recordings. So they put a limit to how big your program can be because they're actually recording it, and then they let you step backwards and forwards through the recording. So they even give you a little slider here. Okay, that's real clever, but the price they pay is they have a limited size of a recording that they can record. Dr. Java is not recording anything. It's literally stepping through your program. And every time it makes a step, it forgets it just forgets what came before. So there's no way to go backwards, but it can step through an arbitrarily large program. You can just keep stepping and stepping and stepping and stepping through arbitrarily large programs. Here, if I do something funny over here, like if I make size 100, I exceeded the visualizing step limit. They didn't have room to record that many steps. I'm trying to draw triangles that are huge. And if I go here, I can see I got part of my output. Part of my output's there, not much. I only got a couple lines of my output. They don't actually let you do that many steps. Their step limit is not very big. Their step limit's not very big because they're essentially making a recording of all of the steps in your program. They're saving them as a movie and letting you step forwards and backwards through it. Okay, well, see here, they gave me 510 steps. I don't know if that is the actual limit or if the limit varies by how many users there are on their website, but I got 510 steps there. Okay, Dr. Java has no limit on how many times you can click step. You can step through anything. So that's the advantage of this one. That's the disadvantage of this one. This one can do something clever, but it pays a price to be able to do something clever. There's a limit to how many steps it can record. Programming is like that. Sometimes when you want to do something clever, it's because you pay a price. You can get the cleverness, but only at a price. And if you don't want to pay the price, then you might lose the cleverness. Okay, let's see. So we've run out of time. So now we've seen how in Dr. Java to do some of the visualizing of a method that the Java visualizer can do. And again, it was just real quick. If you reset this, if I start all over again, the steps were go to debugger, put yourself in debugging mode, pick up line of your program, and set a breakpoint, then run. So put yourself in debugging mode, set a breakpoint, then run. So you need 3 steps before you to trace through a program. Okay, all right. So let me. Oh, and you can turn off debugging mode at any time. So you can turn debugging mode on and off. And if the debugging mode is off, when you click run, you just run. Okay. All right. So last thing, remember to look for, I'll have review problems probably before Thursday. I'll have review problems. So the exam will be a week from Thursday. Okay, so a week from Thursday will be exam on for loops and if statements and methods. Okay, and I'll have review stuff up there probably before Thursday, but definitely by Thursday. And at that point, just like before, if you have questions about review problems, you can ask questions about review problems and start looking at the review problems and stuff like that. And anybody got any last question before we quit? Anybody got a question before we quit? Okay. If you have questions, send me emails, come to office hours, and okay, I will. Okay, so I'll go ahead and end the meeting and see you all on Thursday. Bye.